Almost there.
Okay.
Still loading.
Mm-hmm. I'm going to try and share my screen too.
Oh, cool. Here we go. Good. So, once again, welcome to the monthly Pivo meetup. Today we have a special guest, Wesley Chan from Google, prolific writer of articles. He wrote a book on Python. He writes about Python, Linux, and other technologies. And today he will tell us a bit about Google APIs in relation to Python. Thanks for joining us, Wes.
Sure, anytime. Just wondering, can you confirm that you can see the slides?
Yep, we can.
Okay, great. Okay, so let me get started. So hello everyone, or dobry večer. I don't know if I pronounced it correct, but if I was visiting, I would probably know a little bit more Czech, just because it's always easier to know a few words in a language when I go visit somewhere. But anyway, that's the best I can do in a short period now. So I am Wesley Chan, as Yuri mentioned. I am a developer advocate at Google. I'll describe that in a moment if you've never heard of that title before. I have my Twitter there. If you use that, you can reach me there. And also, if afterwards, I will take questions, but if we run out of time for questions or you have questions later, the barcode and the short link to the upper right is for an open Google Doc, and I'll add an entry for this event afterwards. But you can see that it's a place where I take questions for people who have attended my talks at various times on different topics. And it's just a public document to sort of like share things. Obviously don't ask me anything personal in there. You can always send me a DM on Twitter. Otherwise, yeah, it's for any kind of general technical question you have about a talk that I've given. And I'm happy to answer. I check it from time to time, not every day, but if you do have extra questions afterwards, that is a great place to go and look. So today I will be talking about using Google APIs with Python. So, obviously Python is a very popular programming language now, and there's all sorts of things that you can do with it, but some people don't always know how to use APIs from specific companies because every company does it differently. With Google, I think sometimes our stuff is a little bit more secure than others, and that makes it a little bit more challenging. So I like to make it so that everybody has a better understanding as to how you can use different Google APIs. So I'm going to show you. And of course, because we are such a large company, we have lots of different products. So each product group has a sort of a different way of accessing the APIs. I'll try and show you as much as I can. I have to be honest, I work on the cloud team. So anything that's related to the cloud side, I know a lot more about, but other departments I don't know as much about, but I will try and expose as much information as possible. So my job title is to enable all current and future developers everywhere, including the Czech Republic, to be successful using Google Cloud and other Google developer tools and APIs. My specific team that I'm on is the Cloud Platforms Serverless team. And I will talk about those. So App Engine, Cloud Functions, Cloud Run, because Python is one of the popular languages for those platforms. It's a place for you to run your code. So that's why I'm going to be talking about those and showing you some code samples. I used to be on the Google Workspace team, so that's the product that used to be G Suite or Google Apps. So that's Gmail, Google Drive, Calendar, Doc Sheets, and Slides. So that is all called Workspace now. So I was there for like 5 or 6 years before I came back to the cloud team. So I know a lot about workspace stuff. I also know a little bit about AI and machine learning. So maybe one day I can come back and do a more specific talk on machine learning. And more importantly, because I know all of these separate Google products, I actually like to sort of like push them together to make them do interesting things that you would not think of doing, because when you work at Google, you usually work on one specific team or one specific product. And because I've been on so many teams, I think it's more interesting to show outside developers, what it's like to build with Google, because to all of you, Google is one company, right? To us internally, it's like, 10,000 different small companies put together. So I like to sort of like make different products work and work well together. So as part of my job, I speak to developers around the world, including yourselves. I make videos, I do code samples, and I make code labs, which are basically, online hands-on tutorials that you can, build something small, learn how to use a different piece of an API, and I write blog posts as well. My background is I've been a software developer for, several decades. Probably the most well-known thing I worked on was I was one of the original engineers that built Yahoo Mail about 20-something years ago. I also teach outside of work, and obviously I'm a member of the Python community. Okay, so there's a beginning and an end. So we'll give you a general introduction to the APIs, and then we'll give you sort of like an overview of cloud APIs. And the reason, for that, besides the fact that I'm on the team, is that we have more APIs than other teams, other products. And so since we have so many, and I'll give you sort of like an overview of what are some of the more well-known ones that people use. And then I'll show you the serverless tools and give you code samples for all the different APIs, including ones outside of cloud. And then perhaps I'll sort of inspire you that you too can kind of use different Google products together to build something useful. And then we will wrap up. Okay, so you are here to learn about Google APIs. Hold on quick second, let me get my thing out. Okay, so with Google, you probably know us for lots of products, right? So we're pretty well known for search and YouTube and Android and Chrome. Those are the things that we are the most well known for. But those are our apps. Those are the apps that Google has spent time and effort building, and that's not necessarily what you have. You can't wait for Google to write all the apps for you, right? So that's why we made a lot of these features that are in our technologies available to you as developers, so that you can add usage of those to your applications instead of just waiting forever for Google to write it, because we can't write all apps on the planet, right? So we're depending on you, and so that's why we're making a lot of our technologies available to developers, so that you can also build your own awesome app using our technologies that we've already spent so many hours and days and years making, really useful. So whether you're building your next, web app or your mobile app, or probably both, you have a chance to integrate some of that technology into your apps, and so that you don't have to build it yourselves. So that's really the big thing. All right, so whenever you're using any kind of cloud API, and also the other thing is the Cloud Console that I'm going to talk about now. Yes, you manage your cloud APIs here, but it also goes beyond cloud. So you'll find the Workspace APIs here. You'll find the Maps APIs here. You'll find YouTube Analytics and Ads APIs as well too, because it's, while most of the features are for the cloud platform, it's a kind of like a general purpose developer console that you can control other APIs as well too. So this is where most of the activity will happen when you're setting up your application. So console.cloud.google.com. So you can go there, you can do it from your Gmail account, you can do it from your corporate Workspace account. But there's a couple of main sections that I want to focus on. So the first one highlighted here are all the cloud platform products. So this is a long list. It's not just what you see that's in the green box. It scrolls down very far down. It's a very, very long way. That's why you see that we have little pins that you can pin the things that you use the most, because otherwise you may have to scroll very far to get to the things that are important to you. So that's not really fun, right? So you manage the products that you're using. So whether you're using any of our compute products, storage, networking, security, any of that stuff, that's all in this list. You go down and you click it and you'll get to that products dashboard. It is also a place to manage your billing accounts. So just to let you know that most Google APIs are free except for the cloud ones. The cloud ones, we charge money just because it's a commoditized service. It's like your electricity, your water, your telephone service. It's you pay based on what you use. But a lot of them are either the APIs themselves are free, or even if they are not free, there's a very good chance that there's a free tier. So you have to exceed the free tier in order to incur billing. But this billing section is really mostly only for cloud platform stuff. It doesn't apply to any of the Workspace or G Suite APIs. It sort of applies to Maps. Google Maps gives you a they give you like $200 of credit every month. I don't know. I don't think it rolls over. But in any regard, it's it's kind of controlled with the billing service here. I think YouTube APIs are free. They're a little bit more restricted, but they are free. So yeah, so most everything is free. The only thing that you really need to give us your credit card for is for cloud APIs. See what else? The IAM and admin section, that is for your security. You manage users like other developers on your, of your application. Security controls and things like that are there. And then the last one is the most important one, I think, is the developers console. So that is where you actually manage your APIs. And I'm just going to go there just to show you what that looks like. So here in your developer console or API manager, there's a slightly different short link, which is console.developers.google.com. This is basically where you check out all your statistics on your application. So what you see here on this screen is the dashboard. So you get a chart to show you how much traffic you're getting, how many errors is your app generating, and how long does your app typically respond to your users. And then down below is all the different Google APIs that you have enabled that you're using in your app, or maybe you haven't used it in your app, but you've enabled it. So we don't turn on all APIs for you by default. You have to go and select. So the second thing that you do in the developers console is pick which APIs you want to use. So you would click on the library tab, and then you get a search bar, and you just type in like Cloud Vision API or Google Sheets or something like that. You just start typing the name of the product that you want to turn on, and then it'll bring up everything that matches. It's a search engine, right? So you just pick whichever APIs you want to use. In this particular sample app, there's a lot of Workspace, Gmail, Google Calendar, Drive, Sheets, and there's also a YouTube API. So this was probably a project that I was working on to demonstrate how to grab YouTube data and then put it into a Google Sheet or something like that. I don't remember. I don't even know if this was mine actually. But anyway, and also if you see a blue box, that probably means I made a video for it. So you can, grab that. I'll give you a link to the slides afterwards, so you don't have to write anything down. But typically, whenever you see a blue box, that means I made a video to kind of like show you how to use whatever it is I have on the screen. Okay, so yeah, so that's this is the dashboard I mentioned, and the libraries where you turn on and off APIs. And then the last one is the credentials tab. So in order to use our APIs, you have to have authorized access. So we have 3 different types of credentials. We have the API key, we have the OAuth client ID, and we have service accounts. So those are like 3 different ways to get authorization. And depending on the API and what level of security they require, you'll be using one of those 3. Okay, so just a heads up, before I give you a link to get to the client libraries, I want to tell you that there's 2 different styles of client library. We have something which is lower level, which I call the platform level client libraries. That supports multiple products. But you have to manage your API service endpoints. In other words, you have to set up your API service, and then you use it, of course. Then you have to manage your authorization. You have to go and show, hey, these are my credentials. Please give me access to the API. And so this style of client library you'll find for Workspace. You'll find for Google Analytics, for YouTube, for ads, and things like that. And so there's another link on the next, the link I have here is the same one as the one on the next page. And then there's the product level client library. So this is where you have a client library that's made specifically for specific products. Managing of the API service endpoints and the security is mostly taken care of. You typically don't have to enable or get these API service endpoint. You typically don't have to manage the authorization. That's kind of taken care of under the covers for you. All you need to do is create a client in order to use these services. So for example, Cloud uses the product level client library. So for every cloud product, there's a separate client library. And I'll show you this as well too. And then Google Maps also has product level client libraries. And then a lot of API families support both. So for example, with cloud, as we will see in one of our examples, you can do it either the product level way or the platform level way. And the reason why you would do the platform level way is because maybe you're using more than just cloud. Maybe you're using other products. Like the ones that are in bold here, because they naturally use the platform level ones. Anything that's bold is typically what people would use, okay? So maybe if I'm working on a cloud app, but it also has workspace APIs, and that's a demo I'm going to show you later, you probably want to use this one because then you at least have sort of like a common way of interfacing to these APIs. So anyway, so that I just want to mention that, and I'll show you examples of both so you get an idea. All right, obviously, because I'm talking to a Python user group, my demos here are going to be in Python. So for example, the platform level client library is available at this link, which was on the previous page. But if you're using cloud and cloud only, then you can consider the, the product level client libraries in Google Cloud. But, outside of Python, we support, most common languages that developers use today. Okay, there's 3 different authorization credentials. I mentioned this when I was talking about this in the Cloud Console section, right? You can either use API keys, so those are used to access public data, like searching for things, that locations like Prague on a Google map, or searching for a YouTube video. Some GCP stuff is also public, so just keep in mind anything that's simple, where you're accessing public data, it's not private data. All right, you can use API keys for, just because it's the simplest thing and there's really no protection. You can restrict use of API keys because you really don't want to lose them, because they're, once you lose it, then if people can get access to your API key, they can access the API on your behalf, and they can chew up all your quota. They can do really bad things and just get your account shut down. So you really don't want to let your API keys escape. You don't want to lose it, or worse, you don't want to accidentally upload it to GitHub. It's a very popular thing that people do, unfortunately. So just be careful. Now, everything else is private data, so that's why access needs to be authorized. So if you want to access data that's owned by a human user, you would be using OAuth client IDs. So security comes from OAuth, of course. So the owner of that data must grant permission for your app to access their data. So it's very specific. And the access depends on what kind of permissions do you want. Do you want read-only access? Do you want read-write access? And things like that. So that comes in the form of scopes. So if you're ready to do this kind of stuff, you will no doubt start looking at an API, and then somewhere in the API documentation, it's going to say you need to use this scope. So a scope is just a user permission that you're asking for. When sometimes you run an app for the first time, you get that little window that says, this app needs your permission to do such and such. That is exactly what the OAuth client ID user scopes are. It's listing out what those scopes that were requested by that developer. And so this is typically used by Workspace and YouTube apps, and some GCP as well. Then the last one is surface accounts, where you're trying to access data owned by an app or a robot user. So this is typically what you would use in cloud, because generally it's like cloud-to-cloud communication. There's no human. The human doesn't own the data. It belongs to an application, which is another cloud project. So security here is done by OAuth or JWT. And so the project that owns the data will grant permission implicitly, so there's no OAuth window because there's no human there. And so to make that happen, you need a public-private key pair. And then the access granularity here, instead of user scopes, it's determined by the permissions in your cloud identity access management stuff. And you have to request those permissions for that key pair. All right, so that's why every time you try to access a cloud account, a cloud service or a cloud data with a surface account, you need to have a key pair. Just creating the surface account by itself is not good enough. You must have a public-private key pair. So this is mainly used for GCP APIs. All right, so which do you choose? I kind of gave you a hint already that simple APIs is where you're accessing public data, like searching for YouTube videos and places on Google Maps. You don't need to have OAuth, so it's good enough. Otherwise, you'll have to consider authorized access for everything else. Like maybe you want to add a new video to people's YouTube playlists. That is not public information, or obviously that belongs to a user. or if you're accessing somebody's Google Drive files, or you're accessing, some cloud data, you definitely need to have OAuth or, like I said, JWT. So that's how you kind of determine. And each API will have its own documentation that tells you which one that you need. Okay, all right, I already described that. Okay, great. So basically, no matter what style of API you're using, generally they work like this. It's very much of a request response workflow. So your application will make a request to an API. It has to get past the security border here. Once that's done, the service gets your request, it processes the data, and then it has to ensure that you have enough security, and then it processes the request, and then it sends the data back. So very, very client server. And this is typical, so this should not be a surprise. All right, so let's move on to Google Cloud. So Cloud Platform has lots of different APIs. Obviously I don't have time to cover all of them. It's just too much, right? So I'm just going to cover the most popular ones. But I'm just going to sort of like run through a couple of the ones that you may be familiar with or that are pretty popular. So Compute Engine is just virtual machines. That's pretty easy. You can get anything from a very small, what we call the F1 micro VM, which, by the way, everybody gets this for free every month. You get like 20, I think you get just, whatever is the CPU time and the memory time for F1 micro VM. You get one VM for free every month, basically, all the way up to a very giant, massive machine with 416 vCPUs, almost 12 terabytes of RAM, and 256 terabytes of disk. But, this machine is very powerful, but it's really expensive. So, unless you want to pay, $80 US an hour, probably stay away from something this big unless you have to have it and you have the money to pay for it. And then, of course, we support most versions of Linux as well as Windows Server. And you can also add GPUs and TPUs to it if you need to perform any kind of machine learning training or anything like that. App Engine I'll talk about later. This is where you have an app, but you don't want to think about how many VMs do I need? Do I need to get a load balancer? Do I need to get a database server or something like that? You really have to think about that. You just upload your code to Google App Engine, and App Engine runs your app for you. So you don't have to think about infrastructure. And then similarly, we also have Cloud Functions. I'll go over this as well too. So basically, it's like App Engine, except maybe you don't have an entire app. Maybe you just have small Python functions that you want to put online. That's what Cloud Functions is for. And then one of the last ones is Cloud Run. So this is where you have a container and you want to run that online without having to think about infrastructure as well. So you can consider Cloud Run. There's also Kubernetes Engine. So if you're managing a lot of Docker containers and you have different services running at the same time, and you sort of want it all managed for you, but you don't want to maintain your own Kubernetes installation in your own data centers, this is basically the cloud version of a Kubernetes service. It's fully managed for you so that you don't have to worry about it. Still the same thing. Still the same normal Kubernetes that you would do on your own, except now you don't have to think about the hardware because we give it to you. All right. There's also storage. So cloud storage is like your big disk. There's also file store. So instead of like a big giant data lake where you throw all your massive binary blobs in it, which is cloud storage, cloud file store is more like maybe you want a NAS, an online NAS, basically like mounted NFS file system. That's what cloud file store is for. So they're slightly different depending on what you need. I will say that file store is more expensive because it obviously provides more services than just generic blob storage like cloud storage does. We have relational database, so Cloud SQL. We support 3 of the most well-known relational databases out there, and you can also choose a little bit about your hardware configuration. We also have NoSQL. So Cloud Firestore is basically, our previous NoSQL database was called Cloud Data Store. But then when we acquired the Firebase real-time database, the Cloud Data Store team was like, ooh, we want some of those features from Firebase because they're really awesome, especially the real-time stuff. So what they did was they grabbed a lot of features from Firebase and they merged into Cloud Data Store, and then combined together, they call that Cloud Firestore. So that's the latest one. So, and then we have, because Firebase still exists, And we also have Firestore. We have a page that shows when you would use the Firebase real-time database and when you would use Firestore. Most of the time, you would probably pick Firestore because it's more robust. It's not just a real-time database. It also is way scalable and responds pretty quickly. And then if you have sort of an older app and you're trying to choose between the original Cloud Data Store and a new Firestore, there's also another page to help you make that decision as well. We also have BigQuery. This is a pretty awesome tool. I'll show you a demo of this one. But the cool thing about this one is that you get a you can do here. I'm trying to describe it in the easiest way possible. It lets you analyze multiple terabytes of data with just simple SQL. So something that you cannot do with a relational database because you just can't put that much data in it. But with BigQuery, you can put as much data as you want into BigQuery, and you can just use simple SQL to do queries on it. So I'll show you a quick demo of that. PubSub is our message queue service. So if you've ever used, something like Kafka, this is sort of like our version of it. We also have some machine learning tools as well too. So one of them is, since you're right in the middle of Eastern Europe and you're surrounded by 6 different languages, or at least 6. People are always asking, is there an API for Google Translate? And so that's what the Cloud Translation API is. Yeah, so that's pretty straightforward. We also have the Natural Language API. So whereas the Translation API is just to translate between one language to another, the Natural Language API helps you understand the contents of text. Whatever language it is, right? So it gives you understanding. You can perform sentiment analysis on it. So is this text positive or negative? You can classify the content. Is it a city? Is it a company? Is it a country? Or is this like weather related, or is this news related, or is this technology related? So that's classifying content. Entity extraction is what I was mentioning earlier. Is this a place? Is this a building? Is this a company? Is it a country? And then it can also do syntactical structure analysis. So like, is this a subject? Is this the noun? Is this the verb? Is this an object? So it knows how to sort of extract that information out, and it supports different languages. We also have sort of 2 visual machine learning APIs. So Cloud Vision and Video Intelligence will help you understand the contents that are in images or videos, so that once you pull out the metadata, you can kind of figure out what is in this picture or what is in this video. And then lastly, we have Workspace, which again used to be G Suite and Google Apps. So that's Gmail, Google Drive, Calendar, Docsheet, Slides. I mentioned that we have APIs behind these 2, and we also have they're not just applications that you can use, but you can also access their data by using the APIs. So it's pretty cool. So yeah, that's that. All right, so let's move into some serverless tools. Let's talk about serverless and then show you some code samples in Python. So this is sort of like the main part of the talk. All right, so I mentioned that we have Compute Engine. We have VMs and big disks like cloud stores, but why would you consider this? The reason why I say that is because if your purpose of getting a VM and big disk is to run an application, you have to do lots of extra work before you can get your application to run on it, right? You have to choose the operating system, right? You have to determine what the operating system is. Do I do Windows Server? Do I do Linux? If I do Linux, which distribution? And then on top of that, what kernel version? So there's a lot of decisions to make. You do that, you have to pick the OS, then you have to pick the database server, the web server, then you have to do security patches, and then you have to do all these different things, right? And we think you don't have to do that. If your whole purpose is to running an application on it, then why are you doing all these other things, right? Your job is a software engineer, not as a sysadmin or DevOps person, right? Unless, of course, that's your job, right? In which case, it's perfectly fine, all right? But typically for application developers, they don't really need to worry about these things. So that's why we have serverless. So obviously, serverless is, kind of a, it's a lie, right? There's obviously servers, but the main idea is that it's nothing you need to think about. You don't need to think, should I have 2 instances up? Do I have to have 6 instances? You don't think about those things. We will help you with that depending on how much traffic your app is getting. If you're not getting much traffic, then you can just have one instance running. If you're getting a lot of traffic because you're going viral, we can see the network traffic coming in and we will spin up more instances for you. So that's one of the cool things about serverless, is that if you go viral, auto scaling is your new best friend, because you don't have to think about it. You don't have to think, oh no, I have to spend another, 9,000 US dollars on more servers, or, and you have to keep on thinking, and then maybe your traffic starts going down and you've already spent this money, and now you have a lot of expensive costs to run your company, right? So auto scaling is great, and the cool thing about serverless is that it also scales down. So maybe you're not that successful. Maybe nobody's calling your app at all. So one of the best things about serverless is that if your code is not running, that means you don't have any instances up, which means you're not incurring billing, which means you're not paying. So, versus a VM, you're paying for it 24/7, right? So that's one of the cool things about serverless. And the other thing, of course, is one of the fastest growing segments in cloud. And according to analyst research, companies overall around the world are spending, the amount of money they're spending, 1.9 billion US dollars in 2016. It seems to be doubling every other year. And so we'll see if at the end of this year, it's going to be near 8 billion US dollars or not. I think the pandemic might have slowed things down, but this was the marketing, the analyst research in 2018. So we'll see. All right, so that's serverless. So let's talk a little bit about App Engine. Why does App Engine exist? I kind of already gave you a hint, right? You're working on a solution, you're building the code, but then you have to worry about all these other things: the operating system, machines, the web server, the database server, all these things, right? It just slows you down. And by the way, all apps need these things, not just your app. So every time you build an app, you have to worry about these things. That's terrible, right? So you should really only worry about the solution that you're building and let App Engine handle all this other stuff, like the database, the operating system, auto scaling. At least make it available in different languages that we can support. And please give me a local development server that I can test with. But really focus on your app and not DevOps stuff. So the original product team, when they built this, they took all these little brown boxes, they jammed them into one large box called App Engine. They made it available in Python first, and then Java, and then Go, and then PHP, and then now Node and Ruby as well too. But here's your Python minimal viable product, or MVP as we like to say. The world's smallest Flask app, pretty easy. All of you should understand how this code works. You have one config file that says what is your runtime. You can choose Python 3.7, 3.8, 3.9. Here's my Flask app. It's just a simple hello world, and then I have to list, what are the pip install packages that you need to have installed. So I want to use at least any Flask, at least 1.12, which is the current version right now. And then once I have this sitting in my local directory, I can, and I download the Cloud SDK, I can just type gcloud app deploy, answer the question like which region I want to deploy this to, and maybe some other questions. And then in less than a minute, typically, I will have an app. I have a domain name. I can access this app anywhere on the planet. It's great. And of course, if it's for your company, you can map a custom domain to it as well too. But you too can do this at home now. You can get an app up, available to your relative who maybe lives halfway around the world. Okay, so it's great. This code is part of the Quick Start. So if you want to try the Quick Start, there's a link to it down here. All right, maybe you don't have an entire app. Maybe you don't want to think about frameworks. Maybe you don't have, you don't want to worry about a LAMP stack, a mean stack, or any of these giant stacks, and you just want to deploy, Python functions. That's what Cloud Functions is for. Like App Engine, you can trigger them with HTTP. But one of the cool things that Cloud Function does that App Engine cannot do is that you can make a Cloud Function execute based on a background event. Like, oh, I got another message coming in from PubSub, the message queue system. Oh, somebody uploaded a new file to cloud storage. Oh, somebody logged into Firebase on their mobile app. So you can actually make Cloud Functions happen based on any of these background events. So it's pretty cool. Like App Engine, though, it is also auto-scaling and very highly available, and you also only pay if your app, your function is being called. You can develop on the command line like App Engine, but another thing that App Engine can't do is let you develop completely in your browser. So from the Cloud Console, if you go to the Cloud Functions page, you can actually create your function, You can code your function, deploy your function, and test your function, all from the same, set of pages, basically, under Cloud Functions. So that's pretty cool. If you want to develop locally, we have a thing called the Functions Framework that lets you do that. It basically sort of like copies down the bare basics of Cloud Functions. You can test locally. You can get everything perfect. And then what it will do is, well, I'll tell you what it'll do later, but you'll end up deploying it to Google Cloud, and then it will be available in the cloud for you. Okay, more on Functions Framework a little bit later. And then it supports roughly the same languages, maybe a few more than App Engine does. There's also a special mobile version of Cloud Functions called Cloud Functions for Firebase. It's exactly the same as Google Cloud Functions. The only difference is Google Cloud Functions has more connectivity to other cloud services, whereas the Firebase version has more connectivity to Firebase functions. So if you're using Firebase to build your mobile app, then definitely consider using Cloud Functions for Firebase. All right, so here's your MVP for Cloud Functions. Single hello world function, pretty easy. There's no config file, so that your deploy command line is going to be a little longer. Okay, and then just like with App Engine, in about a minute, you can access your Cloud Function globally at a custom domain, custom URL that you get based on your region deployed to, as well as your project ID. And then this is also part of the Cloud Functions Quick Start. All right, so while this has all been happening, containers have been becoming very popular, right? You get, a lot of times with Cloud Functions and App Engine, we tell you, oh, it supports these languages like Python and Node, and that's great. But maybe you have like a C++ library, to analyze images. You can't upload those to Cloud Functions and App Engine, right? So it's kind of a bummer. So I have to use a container, all right? But what's cool is that I can pick any language I want now. I can use any kind of library. I can even use binaries. And containers give you, a nice ecosystem of base images you can use. And of course, containers is kind of like the common way of deploying applications now, because you have a nice packaged thing that you can run on a VM. You can deploy to Kubernetes. So you have lots of options. So containers are really, really flexible. And the people that do containers also want to do serverless as well. The problem is, like I said, App Engine and Cloud Functions don't support every language. And maybe my application needs to use a binary. Or I don't want to develop for a platform that I can't easily move off of. Why do I have to choose between the flexibility of containers and the convenience of serverless? Why can I not get the best of both worlds? And the answer is you can now with Cloud Run, because this is basically serverless container service. Serverless container service. So you have the flexibility of containers, meaning you can choose any language, any library, any binary. The only thing we ask of you is, for your container, make sure you leave an HTTP port open for us. Typically, it's 8080. And it should be stateless, so that if your app calls into your container multiple times, you're not going to have any bad side effects on your data. Okay, and then you just throw it together in a container. You can use Docker, you can use Cloud Build, you can use build packs. And then your container goes into the container registry, where we make sure that there's nothing suspicious about it, that it's safe to use. And then once it's in the container registry, then you can deploy the Cloud Run, whether you're using the fully managed Cloud Run service or you're using GKE. We have Cloud Run also supports GitOps, so that you can do push to deploy from Git. Of course, this is mostly deployment more than integration. But yeah, if you do you can set it up so that a Git push will start a cascading chain of events that will lead to building your container and then deploying it on the Cloud Run. So you can do that too. So your MVP is almost like almost identical to the App Engine one. Yeah, this is your hello world. The only difference is now we have a startup line to start up the Flask development server. But your requirements, that TXT file is the same pip packages. It really, like I said, you can use any language. We actually have quick starts in these 10 languages, but you can really use any language you want. And then this is part of the Cloud Run quick start that you can go and use. You can use Docker if you want. You don't have to. So most of the time when people do containers, they kind of think Docker file. But it's really tricky to build the right Docker file, because you can have sort of an inefficient container, which means it takes longer to build, it takes longer to deploy, and it slows down startup of your app. And so you really want them as minimal of a container as possible. But not everybody can work on that can create a Docker file that creates such a efficient image. And so that's why, if you don't have Docker file, that's fine too, because we use build packs. So if you know build packs, it's an open standard where the build pack system looks at your code to figure out what packages you're using, and it builds the most optimal image based on what you're using. So anyway, so to deploy, you have two different ways of doing it. If you want to do it step by step, you can build your container with this Cloud Builds line, and then you can deploy that container to Cloud Run. Or you could say, you know what, I'm really lazy, I just want to do everything in one shot. So you could just do gcloud run deploy, the service name, and then say, I'm using the source code that I'm in the directory right now. It doesn't matter which way you do it, whether you're doing it this way or this way. In less than 60 seconds, just like Cloud Functions and App Engine, you will have an app, your containers available globally around the world in about a minute. So that's it for that. Let's move on to some other APIs before we wrap up. So BigQuery, this is where you can analyze multiple terabytes of data with just SQL. So this data set I have here is just Shakespeare, so it's not multiple terabytes because he only wrote plain text. He didn't have a lot of multimedia back then. He didn't have a lot of big data. So anyway, so all his works fit into, I think, like less than 40 megabytes of text. But this is still a task that's still kind of difficult to do as a human. You don't want to really do that, right? So if your boss told you to find the most common words out of everything that Shakespeare wrote, you don't want to really count up those things on a piece of paper, right? So you want to issue an SQL call that goes and does that, and give me the top 10 in descending order, right? So you just have a very simple Python code. There's only 4 lines, right? Here's my BigQuery client. Then I say, here's my results. Here are the headers, the names of the columns, and then here's my actual data. So do anybody know what the most common words in Shakespeare are? Any guesses? If you guess that would be correct. So yeah, 30,000. Can you imagine writing 30,000 check marks on a piece of paper? It's not good, right? So yeah, so and is next. So anyway, so this is something you really don't want to do by hand. So that's BigQuery. It's pretty cool. And we also have like really big data sets that you can try this on. You can like all of Wikipedia from 2015, all of GitHub from around that time, I think, as well too. So we have lots of big data sets you can try, and you can do it for free because we have this thing called a BigQuery sandbox that lets anybody try BigQuery. You can make up to 1 terabyte of queries every month for free. You don't even need to give Google your credit card. You can just try it for fun. Okay, so that's one of the cool things about BigQuery. It's the only product in cloud that you can use for free without a credit card. And we have lots of different public data sets. The ones that are in BigQuery you don't have to pay for, but if you want to load your own data set or use these other public data sets, you do have to import them into BigQuery, and you do have to pay for the storage. But for the ones that are already built into BigQuery, you don't have to pay for the storage. You only pay for the access, and you get 1 terabyte of queries a month anyway. Of course, because of COVID, there's a lot of COVID data sets as well too. And by the way, a lot of people don't know, we also have a Cloud Life Sciences API that does genomics processing. We also have a healthcare API that helps move data between different healthcare systems and things like that. So just in case you're interested in that kind of stuff. Moving on to Cloud Vision, this is where I want to analyze a picture to see what's in it. So all I do is create a client to the API. I want to detect all the labels in this image, which is what are the objects that you see, and then print what those labels are and the confidence score. So for this picture, okay, it sees that it's 95% confident that there's people in this image, 89% sure it's a street, transportation, vehicles, and things like that. So this is Cloud Vision. I created a Vision API code lab to get you up to speed. So this is one feature, the label, but it also does landmark detection. It does OCR. It does a bunch of other things. So the code lab teaches you 4 different features of Cloud Vision. You can also work on Hangouts chat. So if you use Workspace and G Suite at work and you're using chat, you can actually create bots, which are kind of cool because you can make automation happen based on asking for something in a chat room. Like, can you move tomorrow's meeting with this person to another day? and the bot can say, let me check it out, and I'll physically move it. Or I could say, my people that are working for me, I want to find out how far they are in their task. So I can ask that in a chat. Or who's the contact information for this person, bring it up. So you can make bots do things for you. Okay, so it's pretty cool. So here's one in Python and Flask. So I got a message. All it does is just display the message that they had. So like if I type testing to this bot, it just returns hi, my name, and then I sent, and then here's the message that I sent. Okay, so this is very, very basic bot that doesn't really do too much. But you can put a lot of stuff in this code, right? You can look things up in a database. You can go call some service that's online. So you can do all kinds of crazy things. Here's an example of YouTube. So YouTube is not cloud. It's another Google API. So this is where I'm searching for Python videos. Yeah, but if I just search for Python, I get a lot of snakes. So I have to say exclude all snake videos and then give me a list of give me the links and stuff like that. So that's YouTube. Maps. So for example, here's a famous house, I think, that's in your city. So I wanted to learn more about it. So I pass it into Google Maps. Here's a client for Google Maps. I want to geocode this street address into latitude, longitude, and then I'm going to reverse order, give me a street address. So there's that. And then here's my place query for this well-known house. You can probably tell me about it over beer sometime. But I looked at it. It looks pretty modern for having been built in the 1920s, I think. And then Google Maps has a bunch of APIs as well too. And then, so to kind of wrap up, lots of different APIs. So Firebase is our mobile development platform plus real-time database. You can also access machine learning stuff using the ML Kit. Google Data Studio, if you don't know it, it is a way for you to build a beautiful dashboard based on some data source that you have. So it knows how to read data out of lots of things. It knows how to read out of Twitter, out of a Google Sheet, out of CSV, out of BigQuery. It knows how to read out of lots of things. And if it doesn't exist for your data type, then you can build a connector to connect to your data set, and it builds a really nice dashboard. And of course, it's free. So you can learn more about Data Studio. If you want to build voice-driven chat apps, not just the typing kind that I just described, use the Actions on Google service that lets you use Dialogflow to build things for the Google Home, Google Assistant, and things like that. As you already saw, YouTube has APIs, Maps has APIs. And also, if you want to build a native mobile app that works on Android and iOS, as well as the web, but only have one source base, you can consider Flutter. The only issue is it's not in Python. It's in another language called Dart, which is sort of like a modern version of JavaScript. So that's the only catch there. So those are other development platforms. All right, so the last thing I want to show you is an inspirational app. What happens when you put together Workspace, G Suite, and GCP together to build an interesting app? So this is in Python. It's a cloud image processing workflow. And let me describe what this does. So I don't know how your Google Drive looks at work, but at my workplace, because I'm always making videos and code samples and blog posts, I always have images everywhere. My drive is a mess. I cannot find things. I have to scroll down past all my drive folders in order to see the documents that I'm working on. So I think that if you work in an industry like architecture or manufacturing or the media, I think people that work in those industries have even more images than I do, and their drive is probably even more messy. So why can't I take some of those, projects that I used to work on, maybe a year or 2 or 3, maybe I don't look at those images anymore. Maybe I want to archive them somewhere so that I can at least get my control of my drive back, So that's the purpose. So I have lots of stuff on Google Drive. I want to back them up to cloud storage. So that's moving them from Drive to cloud storage. And then maybe I want to categorize that image. What is in that image so I know something about it? So I'll call Cloud Vision to look at those images that I'm backing up. And then I want to write down the results in a Google Sheet, right? So I can see what I've backed up. Okay, so I want a sheet that looks like this, where it has all these images, what kind they are, what is their date and time stamp, and then maybe what's in those images. And I want them backed up, erased from my drive, but I want to get a link to them so I can go and get those on cloud storage if I ever need them. Okay, so that is the enterprise use case here. So I'm not going to show you the entire application. I'm just going to focus on certain things. So the driver app, which is main, will call these 4 functions. So that's the calls are in bold italics. So one call to get that image from Drive, I don't delete it here. I'll leave that up to you to add the delete part. But I will, this 4 lines of code will download an image file from, or any file from Drive. Okay, that's it. Then what I'll do is I'll upload it to cloud storage. So these 2 lines of code is how you create a new file on cloud storage. Then I'll pass the image to Cloud Vision. So these 1, 2, 3 lines of code will take the image and will ask the image, the Vision API to annotate and give me labels. And then I will grab the top 5 labels, I think the top 5 labels. I'm sure I have that number somewhere, and then store them into a sheet. That's the last row. I mean, sorry, the last function call. So these 2 lines of code will take that row of information and store them into a sheet. So by the time I'm done, I will have something like this. So it's pretty short. You know, you do it in Python. You know, Python is very, you know, it's pretty robust, so that you don't, it's expressive enough where you don't have to use a lot of lines of code to get things done. So, you know, in about, you know, this is less than 100 lines altogether. Obviously, there's lots of stuff that I'm not showing you here. This is the core part of each function, and that's it. So I created a blog post on this. This is also available as a code lab. It's about an hour, a little bit more than an hour, where you can, you know, build this application line by line, and I explain fully to you. Or you can just say, I don't need lessons, just give me the code. Take a look at it at this link here. And to wrap up, let's just, you know, to summarize, Google is more than just apps. We're more than search and YouTube and all our famous apps. We've made a lot of our technology available to developers using APIs. Workspace is not just a set of apps you can use. You can actually code them, because Drive and Calendar and Gmail and Sheets, they all have APIs. And of course, you already know GCP has all these well-known, you know, services, and serverless is great because then you don't have to think about infrastructure and operating systems. You can just focus on your solutions, and lots of possibilities if you use multiple APIs, especially the ones from cloud, right? If you mix Workspace and GCP, you can build some pretty cool stuff. And of course, we have a lot of other useful APIs as well. So here are some links that you can go to after this talk to get started. Here are some intro code labs for, you know, Workspace and AppScript and App Engine, Cloud Functions, Cloud Run. There's a lot of videos, a lot of code samples. If you want to learn more about what's free, what's not free, take a look at that link. If you are familiar with using AWS and Azure, and you sort of want to compare what is the GCP equivalent to this product I'm familiar with, there's separate pages for that. And that is it. My daughter says hello. She loves drawing these little anime characters. But I don't know if you also notice that there's progress bars on the bottom, because Google Slides and PowerPoint don't really have progress bars, I don't think, yet. So one of my colleagues built these progress bars using JavaScript, and these are AppScript as a Google Slides add-on. So you can learn more from that link. And then the slides for this talk are available at this barcode or this short link. So that is it. Thank you very much. And I can ask you if you have any questions.
Well,
I'll turn it back over to Yuri, by the way.
We've got 2 questions so far.
Okay.
It's going to be from me as a warm-up.
Okay.
Out of all of those APIs you contributed to, which one you enjoy to work on the most?
Oh, well, that's a really tricky question, because either I have to work on them because it's work related and I have no choice, or do I really enjoy working with them from the developer's perspective? So I'll give you the second one first. Oh yeah, one-on-one. Okay, so I have to talk about App Engine because that's my work. One of the cool things about App Engine is that it's been around. It's our oldest cloud product. It's been around for many years. And now we have sort of like the platform has evolved so that there's a more modern version now. And so my job is to help people migrate and modernize their apps to using the new platform. So that's like what I have to do for my job. And then I do enjoy using the Vision API that I showed you. It's really, really easy to use, a lot easier than I thought. So I showed you an example of getting items that are in an image, objects that are in an image. But using OCR is pretty cool. Doing landmark detection is pretty fun, especially it lets you explore different places, different landmarks and things like that. So it's pretty cool. Another thing I enjoy, part of my work, is I like to talk to students at universities. and students can do lots of cool things with our machine learning APIs. So I was thinking machine learning stuff is really fun, but I myself was not trained in, I didn't take any AI classes when I was in university. So I don't have a lot of that background, but the APIs make it easy for me to like learn, even though I'm not a data scientist, I'm just an application developer. And so it really makes AI a lot easier. So that's why I enjoy using those. So I hope that was a good answer.
Yep, thank you very much. And we've got one more, and that's perfect segue from what you said about students using APIs maybe creatively, because what creative, ingenious, or unusual ways of using the API you have seen?
Yeah, that's a good question. I think I'm coming up, as a person in my particular role, generally we only focus on one product. And so that's why, the reason why I was telling you guys about this sample about backing up images and things like that is that it is a way to leverage multiple Google technologies that really aren't that related to each other, but you put it together and you make something that could be potentially useful out of it. So, I've seen, so like, as far as like, so that's something that I wrote, of course. I think it's pretty cool. It's interesting. It's not just, write a demo that uses 3 different Google APIs or something like that. It was really trying to figure out what is the real problem. And I actually do have a real problem with my Google Drive. It really has too much stuff in it. But like seeing something like in real life that was pretty cool is, I don't know if in your city you have these bicycles where you can borrow them for a certain time. Like you get 30 minutes for free, and then every hour after that you pay maybe $1 or something like that. A lot of the big cities have this, like New York and London, where you can rent these bicycles. And I remember that the system in London, they knew nothing about App Engine. They knew nothing about Python. They wrote an Android app to help manage users looking for bicycle stations, where they can return them to, where they can borrow them from, which ones are not empty. And they needed to store that in the cloud, but they didn't know how to do it. So they took one weekend, like on Saturday and Sunday, they learned Python in 2 days. And then the next 3 days, they wrote an App Engine app that managed the back-end storage for all the inventory data for, where are the bicycles located, which ones have slots to return a bicycle to. And then they attached that to their mobile app, and then they launched public to the city of London on a Wednesday. So it took them, like, I gave them the talk on like Thursday night, and they launched this on Wednesday, the next Wednesday. So it only took them 6 days to do it. So I think that was pretty shocking. How cool and
on the 7th day.
Yeah, exactly. And the craziest thing is that neither of the developers knew Python, right? Because they had thought about doing it in Java, because of course the Android app was in Java. They didn't have Kotlin at that time, so they were thinking about using Java App Engine. But to them, using brand new Java libraries is almost as hard as learning a new language anyway. And of course, Python lets you develop much faster. So that's why they picked Python to do that. So that was probably the most shocking example. And I even wrote a blog post I can send to you guys later, but it was just like amazing, because I remember talking on Thursday in London to the user group meeting. Crazy. Good question though.
Yeah, that's very cool, very cool. Thank you for that. I will definitely use it as an example on why to learn Python maybe is even a first language development.
Right. Great.
Easy. And I can't see any more questions. So if anyone has a question, please ping as soon as possible, because then you can ask unrelated questions or then move into the free talk.
Right. By the way, does everybody have the slides, so I can turn off the sharing so I can just look at all of you? Everybody has a slide link. I can almost email it. I can also email it to you, and then you can send it to all the members as well too.
I think you can share it here in the chat, and we can also add it to the Facebook event and to meetup.com and Pivo pages.
Okay, so I'll drop it here.
Did you share it with me before?
I don't think so.
Yeah.
All right, let me stop presenting. Okay. All right. So sorry, I think I interrupted somebody who had a question. So go ahead, please.
That was you, Jirka.
That was me, yes. Oh, yeah. I didn't have any question. I just wanted to encourage others to, well, even unmute their mic and cam and ask live if they are maybe shy to write their questions in the chat.
Oh, the other thing here is that you can also turn off the recording so that people who don't want to be on the recording can also ask questions.
Good idea. So I'll do it right now and wait for the shower of questions.